Welcome to the CGA-IGC podcast series, brought to you by the CGA-IGC Education Committee and made possible through the generous support of our sponsor, LS Cancer Diag. Each episode aims to bring you an in-depth discussion related to emerging data, clinical challenges, and unique perspectives in the world of hereditary GI cancers. Before we start, we'd like to remind you that the content of this podcast is not intended to replace professional medical advice, diagnosis, or treatment, and the content reflects expert opinion at the time of recording. Keep listening to find out more about this episode's host, guest, and feature topic. And be sure to learn more about our sponsor at lscancerdiag.com.
Hi, everyone. Welcome to the CGA podcast. This is Dr. Thomas Slavin. I'm here with Laura Valle. She is a principal investigator at the Hereditary Cancer Program at the Catalan Institute of Oncology in Barcelona, Spain. Welcome to the podcast today.
Thank you. Thank you for having me to talk about this topic. And I hope we have a great discussion.
We're going to be talking about a position statement that you just had. For those that want to look it up, it's a position statement, the International Society for Gastroenterology Hereditary Tumors on APCI 1307K and cancer risk. So those numbers, if they mean something to you, you are a genetics professional because that is a common variant that we have a lot of troubles with throughout the field. And Laura and colleagues have done some work to hopefully shed a little bit more light on the risk associated with it. So Laura, thank you again. Just wanted to start out, what led to the whole concept of this article?
So as you just mentioned, this is a very problematic allele. It's something that is found in some populations more than others, of course. And it always has brought discussion and trouble in how to deal with the people carrying this allele. So in this context, the International Society for Gastrointestinal Hereditary Tumors, INSIGHT, decided to take some action and form a working group to work on what could be done and what could be doing to improve the management of these people. And so this working group started to work on producing a statement based on published evidence to see if we could get to a more homogeneous management of these people around the world. Because as you may know, different countries have different recommendations for surveillance and for testing this allele.
Yeah, no, couldn't agree more. And congratulations on your recent publication. For those that want to look it up, it was in the Journal of Medical Genetics in April of 2023. I should probably mention that at the beginning. And you really did some nice work here, as you mentioned, with your consortium. So what were the major goals and the findings that you found as you went through the research?
So this group was formed by people from the INSIGHT Council, but also other people that could help improve or review the literature. So what we did is we met several times and we discussed what was important to define. And then we did a literature search to find published evidence that could answer the questions that were there. No? I have to say, if you look at the statement, you will see that there are people from the US, from Europe, UK, and even from Israel. So we try to have a very heterogeneous group with different points of views, which led to a lot of discussion on different points. So we wanted to have a very good review of the literature to see what was the evidence that was available and could help us propose this position statement or recommendations for this allele. And what we did was we first established the questions that we wanted to answer. And first of all, we wanted to see whether this risk allele had different prevalence in different populations, because we know typically it's known to be an allele that is most frequently found in Ashkenazi Jewish. So we tried to see what was the risk associated with cancer in that particular population or ethnicity, and then also in Jews that were not Ashkenazi and in non-Jewish populations, because data are differently published for each of these populations. And most of the studies have been performed in Ashkenazi Jewish populations or populations enriched in this ethnicity.
And as you brought up, it's so prevalent in Ashkenazi Jewish individuals. At 5 to 10%. I think in the paper you said 6 to 10%. Just a very common allele in that population. So what did you find when you really started looking between the populations?
Okay, so what we did is we did this literature review, and then we performed a meta-analysis with everything that had been published. when we studied the Ashkenazi Jewish, we came up with something that had been already known, no? That this allele was present in approximately 11% of colorectal cancer patients of Ashkenazi Jewish origin and in 7% of a matched population of controls, okay? So that confirms that this allele gives an increased risk to colorectal cancer in that population. And the odds ratio was about 1.7, 1.8.
Mm-hmm.
And then we have to know, it's an APC variant, but it doesn't increase the risk to adenomas. And that's what the publications indicate. No, it's not the risk to adenomas. It's a different mechanism, different from the regular
Which is so interesting. Yeah.
Standard APC mutations. So another thing that we saw in that population is that the average age at colorectal cancer diagnosis was approximately 60, 70 years old, which is it's identical to the age of onset in the general population. So this is important because all these studies are quite consistent. It's 67 years old, and then it could be the same as in the general population and at most a couple of years before. So it seems we are safe if we start screening at the population screening age, like 45 or 50 years. Mm-hmm. Okay, so this is important. And it seems like for Ashkenazi Jews, everything was pretty clear. There are a lot of data published and it's very consistent. The risk to cancer is probably or mostly an increased risk of colorectal cancer. And the risk to other cancers is not so clear. We can say there's not much risk to other tumor types, but it is true that for some of the tumor types, the data are very scarce. So it's very difficult to extract clinically relevant information. So in that regard, more studies could be done. But we would say we can focus on colorectal cancer risk for Ashkenazi Jewish. Then we move to other populations.
Yeah, that's what I was going to ask. Yeah.
And that is more complicated. So when we first looked at the other Jews, the ones that are not Ashkenazi, and the prevalence is different. It's lower, of course. It's about 2.5 for patients and 1.8 for controls, which is not significant at all. Mm-hmm. The problem is that everything that has been published is quite consistent. You observe similar percentages and everything, but the data is scarce. It's lacking. And the problem is that with that prevalence, if we want to identify significant differences, we would need much larger sample sizes.
What do you think is causing the difference between the different populations, even though it's the same allele? Why would there be different risks?
Well, we still don't know whether the risks are different. The available evidence supports the risk for Ashkenazi Jewish, and the available evidence, which is very lacking, we need more data, indicates that in non-Ashkenazi Jewish populations, the data indicates there's no risk or the data is not enough to give any recommendations because you cannot extract any conclusions for that. So one thing that could be done is to study whether this allele comes from the same origin. Mm-hmm. Also the ones that you identify in other populations. So is it the same haplotype? Are we talking about the same allele exactly? And if it is the same allele and we observe different risks, then we might want to go further on the genome and see whether there are some modifiers of that risk in that particular population. That's one thing. Or even environmental things that could be also modifying the risk. But this is one thing we need to work on. We need to know first, identify whether all alleles come from the same origin. And if that's the case, and the risks are different, because we still don't know that, we need to go further in the genome and see whether there are some modifiers or things that are providing different risks.
Yeah, for sure. And you had mentioned the lack of data on the non-Ashkenazi Jewish population. Were there any other challenges to finalizing this data? I noticed the homozygous data was very rare.
Yeah, there were two main problems here. One, it's for the non-Jewish population, as you just mentioned. We recopilated or collected all the data that had been published. We tried to do a meta-analysis, and then we realized that it was impossible to do. It made no sense. It was a methodological problem there, because even in non-Jewish populations, there are different allele frequencies in different countries. For example, you cannot compare the prevalence of the allele in Spain and compare it, for example, with GNOMAD data set of non-Finnish European people, because you see that it's different in Spain than in Sweden or in different countries. So what would be very important is to have well-designed, geographically matched case control studies in different populations. Okay? Otherwise, it will be impossible to get clinically informative conclusions. We need geographically matched case control studies. Because, for example, we did this in a specific case control cohorts from Spain, but still the data were limited. And in that case, we observed that the prevalence was 0.17% in cases versus 0.15% in control, which makes not an allele risk. But still, if you want to find something significant with those numbers, you need a very large sample size. So we need very well-designed, geographically matched. And it's very important. And something that would be interesting too is to find genetic or genomic markers for Ashkenazi Jewish descent that we could use in these studies. Because sometimes you have studies from, I've said Sweden because one study comes to my mind where they found one case with one allele heterozygote, and this one had an Ashkenazi descent, and after that they just. So it seems to be almost absent in regionally Sweden people. But then if, people move, so we might find the allele everywhere.
Yeah. Beyond the missing data, is there anything you wish you had at your hands that you could put in the article?
Yes. Something else that was missing is the information on homozygotes, because one might think that you would expect a more severe phenotype, but there are only 13 cases published to date.
Yeah.
And the phenotypes are very variable. I mean, you have homozygotes without any cancer phenotype, even at the age of over 70 years old, and others with very different tumor types. So with those data, there's nothing we can say about homozygotes. And at this point, the only thing we can recommend is the homozygotes to be treated as heterozygotes, because there's no particularly more severe phenotypes in the ones that have been published.
Yeah, I did want to ask about management. You touched on it there, at least for the homozygotes, but I know there were some management recommendations in the paper. Where did the Insight group fall on how to take care of individuals with I1307K?
So we tried to be very strict and focus only on the evidence that was available. And the evidence says that the allele confers low risk, because it's not very high, for heterozygous Ashkenazi Jewish individuals. So this is where you can test the variant and you can provide counseling and surveillance recommendations. For non-Ashkenazi Jews and non-Ashkenazi populations in general, there's no evidence of association with cancer risk. So in that particular case, we recommend standard population screening, starting at the same age. As I've said previously, the average age of colorectal cancer diagnosis for heterozygotes in Ashkenazi Jewish populations is 60 to 70 years old. So it's okay to do the standard population screening. In fact, even for Ashkenazi Jews, we recommend starting at 45, 50 for them.
We
of
just
course,
do it more
maybe
frequently.
every 5 years and depending on the findings, no? But it doesn't seem that sticking to the population screening strategies that we nowadays have that start at 45 or 50 would be enough for them. Maybe a little bit more intensive after that. And our recommendations is to do it in Ashkenazi Jews, not in the others, at least not with what we have now.
Yeah, that's so important, because a lot of times when people think about risk, they just think about what's the added association of a particular allele, for instance, and they don't think about the age of onset change. And I'm so happy to see that your group went to the extra effort to pull that data out, because it's incredibly important, because it frames when do you need to dial down the screening in this population. So that's fantastic.
Yeah, there's this recent study where they considered the cancer risk at different age windows, like 40 to 45, 45 for moderate risk alleles. One of them APC I1307K, and also MOD-Y8 heterozygotes and others. But what they observed is that the risk for an heterozygous for this variant at the age of 40, 45 was similar to the risk for a wild type person at the next 5-year window. So for 45, 49, it was the same risk as the 50, 55 window for the population risk. Yeah. So this tells you that it is very close, and starting at 45 or 50, it's okay.
Yeah, no, very important. So what do you think is needed at this point? I mean, what are you working on as a next step?
So in addition to what we've already said, let's do big studies by countries probably, or even regions. I mean, we need to see whether this allele, how frequent it is in different countries. If it has the same origin as the Ashkenazi Jewish allele, or the ones that we identify in other populations are not related to it. And then there's something else that needs to be done, is to study further the molecular mechanism behind this allele. Because classically, the allele changes one T for an A in an A track, a mononucleotide repeat track of A's. So when you have in the middle, there's a T, which makes it not a very long track. But when you introduce the A, then the polymerase, you can have slippage of the polymerase. And that's probably what could cause truncating mutations in APC because of that, because of the slippage of the polymerase. That's what in vitro studies say and everything. But it would be important probably to sequence tumors from these heterozygous carriers to see first how APC looks there somatically, if it has accumulating mutations, or what is going on there. So studying the mechanism behind it might be helpful to understand how this works and why it increases slightly the risk to colorectal cancer, not to adenomas or other cancer types.
Thank you for doing all this really needed research with the Insight group collaborators. 1307K is a major bane of the challenge of seeing clinic patients for a lot of individuals, seeing patients that have had hereditary cancer testing. Thank you so much for coming on the CGA podcast today, Laura. Keep up the great research and wish you the best, and congratulations on the recent article.
Well, thank you. Thank you for the invitation, and just to acknowledge the work of the whole group coming from Insight.